All right, let's boogie. Example 5, we're still doing the chain rule. This section has a lot of cosines and 5s in it. So on part E, we want to take the derivative. The quotient rule would work here, but again, because we have a constant in the numerator, it's probably going to be a little bit faster if we just bring the entire quantity to the top. And when we do, I'll add an extra set of parentheses around the 5x, just because it's its own layer, right? Anytime your inside function is more than plain old x, you need another layer. Now, in haste, I just noticed some of y'all wrote it like that. Is that correct? No? Do you need another set of parentheses?
I have parentheses.
Well, no? Yeah? Oh, yeah, there we go. Yeah, we do. There we go. Yeah. So I know we're going fast, but you really need to say what you mean and mean what you say. So f prime of x is, for outside in, negative 1/2 blob to the negative 3/2. And again, I left the blob blank. We'll come back and write it in there. And then times the derivative of the next layer, which is negative sign of blob. And then finally, the derivative of the innermost blob gives me a 5. So there were 3 layers there, and we have 3 factors. I used the same color because that's what you'll have on tests and quizzes. So maybe you could separate them with like prominent-looking multiplication dots. Cleaning it up. I didn't make y'all do that on the quiz, but in general, we're going to be using these things, so we want to do that. We have a negative 1/2, a negative, and a 5 that we can combine to call positive 5/2. So I'm going to let the 5 be the placeholder in the numerator and the 2 in the denominator. Here's a factor that ends up staying in the numerator. And then the cosine factor gets kicked back down squares because it's negative, and it becomes cosine cubed of 5x. And I guess we don't need these parentheses up top around our angle anymore. So there you go. That would be kind of the cleaned up version. That 2 in the bottom looks like it's trying to become the root index. There we go. All right. Any questions on that? Inch by inch, it's a cinch. Rewriting it. All right, and the last guy here. What's the derivative of cosine of 5? 0. Good. Can we also say it's equal to negative sine of 5? No, because cosine of 5 is a constant. Now, what if you want to put parentheses around the 5? And now you play stupid like it's cosine of blob, right? Now f prime of x could be negative sine of the blob times the chain rule, the derivative of the blob. What's the derivative of 5? 0, which wipes out everything. So yeah, it could work that way. So it's just a little bit faster to realize that cosine of 5 is a constant to begin with, and its derivative is 0. Is cosine of 5 positive or negative? Well, 2 pi is about 6.28, right? And 3 pi halves is about 4 point something. So 5 radians lands over here in quadrant 1, where cosine should be positive. Should be some positive number. Okay, reviewing the unit circle. Comments, questions on that? All right, we got 2 minutes. Let's see if we can squeeze this in. Example 6, find the equation of the tangent line to this graph at pi. What do we need for the equation of a tangent line? Slope and a point, right? Point and a slope, or slope and a point. All I have is an x value, but I have a function. Let's go ahead and find the y value first. To find y values, you plug it back into your y value machine, which is f of x. So that's 2 sine pi plus cosine of 2 pi. And that's an exact answer, but we'll simplify. Sine of pi is 0, cosine of 2 pi is 1, so we get 1. So the point, if you want to kind of like put it into now a pre-measured bowl, which would be writing it as an ordered pair, putting it right in front of you, there it is. Now we need the slope at that point, which is the derivative. So before I can find f prime of pi, I need to find f prime of x. And that's going to be 2 cosine of x. And then that second term is a little chain rule. So it's going to be minus sine of 2x times the chain rule, an additional 2, which I went ahead and wrote in the front. All right, now I can plug in my pi. F prime of pi That's 2 cosine of pi minus 2 sine of 2 pi. Again, that's an exact answer, but I don't want to have to write all that over again. So I'll simplify. Cosine of pi is -1, so that becomes -2. And then sine of pi is 0, so that kind of wipes out the second term. So I get my slope then to be -2. And here we go. The equation of the tangent line in Taylor form is y equal the y value of 1 plus the slope -2 times x minus the x value of pi. There it is. Okay. Have a fantastic, super duper awesome, wonderful lunch. Sorry I did that one kind of quickly, but should be kind of routine. Just a review.